So question 3 says find the range of values of h for which the line y is equal to x minus h meets the curve y is equal to 9 over 2 minus x at two distinct points. So before I start solving, let me just tell you about these three things. Two distinct points, one point or it's a tangent to a curve and not meeting at all. So before you do anything, you have to solve these two equations simultaneously. You want to pretend you are solving and the problem is solvable until you get to the point where you can't solve it. So let's start with that maybe before I talk about the three conditions. So let's solve these two equations simultaneously. So I'll substitute this in there. So we can cross multiply. This times this will be a 9, and then this side we have x minus h, then 2 minus x. So this times this is 2x, then x times negative x, this is negative x squared. This times this is negative 2h, this times this will be hx. So now we can put everything to one side. This one will be x squared, then this one and this 2x minus hx, and then finally the constants 2h plus 9, and everything here is equal to 0. So now you want to write this in standard quadratic form. So we have x squared. You want to take the x out. So if you want to put a plus here, make sure that you don't forget that these are negative signs. You factor the x out so that this is your b, and then everything else, everything that has no x is considered your c. This is your constant, then your a is simply a 1. So now when you look at the quadratic formula, let me just write it down. So this thing is always solvable as long as you have a positive number in here. This part is therefore called the discriminant. It's called the d. So when you have d which is greater than 0, then remember that all the numbers which are greater than 0, you can think of 9, you can think of 80, 81, they always have two possible square roots. So the square root of this one here will be plus or minus 3, because when I square plus 3, I get a 9. When I square negative 3, I'll get a 9. So if these 2 points are meeting at 2 different points, then my d must be greater than 1 so that I have 2 possible solutions, meaning that the 2 lines are meeting at 2 different points. And then we have another case where, so this one is by discriminant we mean this, by the way. So for AC is greater than 0. And then we also have a case where the 2 are meeting at only 1 point. So in that case, the discriminant is equal to 0 because 0 only has 1 square root. So when I put a 0 there, then I'll only have one square root, which means this quadratic equation will have only one answer. If it's 2, then it will be 2, nothing like plus or minus 2. So in such a case, when you have a tangent line, or when you are told that the 2 are meeting at only 1 point, which is just the same as the tangent line, it means d is equal to 0. By d we mean 4ac, b squared minus 4ac is equal to 0. And then when the two are not meeting at all, the only possibility is when you have a negative number here. Remember, right now we are only dealing with real numbers. So if the two lines are not meeting, the curve and the line are not meeting, it means you can't solve those two equations simultaneously. If you attempt, then you end up getting something like the square root of -4, and then you'll be stuck because you don't use complex numbers here. Okay, so next, so in such a case, we have d is negative, or d is less than 0. That is, b squared minus 4ac is less than 0. So now let's solve. In this question, we've been told that these two are meeting at two distinct points. So the only possibility here is b squared minus 4ac must be greater than 1. I mean, must be greater than 0, because this one, with this, you expect two different square roots, which means you have two different answers. So our b here is this one here, -2. Let me write it. Okay, -2 minus h, then you square it, minus 4. Our a is 1, and then our c is 2h plus 9, and then this whole thing is greater than 0. So now you don't need to get the x variables there, just get the coefficients. So now we can easily solve for b here. So we have -2 minus h squared. Then when we expand this side, 4 times 1 is 4. Then 4 times this will be 8h. -4 times 9, this will be -36, I think. And this is greater than 0. When you square this using the binomial theorem, this one will be a 4 plus 4h, and then plus h squared minus 8h minus 36, which is greater than 0. And then you can put the like terms together. So you have h squared, and then 4h minus 8h, this is -4h. And then 4 minus 36, this is -32, which is greater than 0. And then the product is -32. The sum is -4. So the factors should be, so 32, we have 4 times 8. Yeah, that should be 8 and 4. But because the sum is negative, this one must be negated, so that this times this is that, and this plus this is that. So we have h squared minus, we'll start with 4h, and then minus 8h. Remember, it doesn't matter which one you start with. And then you can factor the h out. You have h plus 4. You can factor the 8 out. You have h, and then you have 4. This is greater than 0. So now you have h minus 8, and then h plus 4, which is greater than 0. So now when you have an inequality like this, or an inequation, you don't just say h is greater than 0. I mean, h is greater than -8 and h is greater than 4. In this case, you have to test. So the easiest method here is you find the critical points first. So in this case, you have an 8 from here. When you take the h to the 8 to the other side, and negative 4. So I'll have negative 4 here and an 8 there. So now I'm going to test this, and that. But you don't need to test them all, because when I test this and I have some positive feedback, then that will be the case even this side. And then if I test this point and I have some possible positive feedback, then this is the only region which will be acceptable. So I'll pick a 0 from here, because I know that 0 is somewhere here, like that. So I'm going to get a 0 and test it in the original equation. By the way, you can even use this to test or that, but I'm going to use this. So h squared minus 4h minus 32 is greater than 0. So now let's put a 0 and see if we shall get a true mathematical statement. So if I put a 0 there, then this and this will all be zeros. I have this. So as you can see, this is not true. So if this is not true, then this is definitely true and this is definitely true. You can't have a true statement here and a true statement there. So that means the only possibilities are these. If I had tested this and I had a true mathematical statement, then I would straight away conclude that I have another true mathematical statement here. There's no need for me to test this or that. So in short, numbers which are this side are all less than negative 4. So you can say h is less than negative 4, or numbers which are this side are all greater than 8. So you can't combine these two. You just leave it like this and you are done.